Hi there. Following the video that I released on pressure, I am going to be, we're going to be seeing 10 questions together, 10 possible questions in the area of concept understanding that you could see in your upcoming JAM. Now, do well to subscribe to the channel if you have not already, and make sure to click the bell notification. Now, I have said in my other videos that understanding physics physics is quite easy if you start from the basics. That is, try to understand the basics. What many people do is try to just jump into calculations and not understand basics first. And that's why they fall prey of questions that are based on concepts. So if you don't understand concepts, you see that sometimes you just get the calculation questions, but you fail the conceptual questions. So with this video, I hope to build your understanding of the concept, and do well to leave a comment below if you really understand at the end of this video. All right, let's go on. I said, the first question says, which of the following best defines pressure? Now, you remember that we said pressure is described as the ratio of force to area, or we say it is the force per unit area. Now, the first option now says the force exerted by a body, by an object on a surface. Now, that seems to be a correct answer because it says it's the force exerted on a body by an object on a surface. But you see, pressure is not just the force. Pressure is different from force. Pressure is force broken down over an area or spread over an area. So if you say it is just force exerted on the surface, that doesn't make sense because this is a force. If I punch this wall, it is a force exerted on this surface. So but it is not pressure. Do you understand? All right. Now the second option says the force per unit. Okay. The second option says the force per unit area acting on a surface. So by just understanding the formula, actually, you can answer this question. So the answer is going to be B, the force per unit area. Let's see the other options and see how because there are four options that you'll be given here. One of which will be a very relevant option, and the other will be an option that want to confuse you. Two of the options will look very much alike. So now, look at this other option. It says the energy transferred when work is done. No, that is not true. That is not true. Now, the resistance to motion, that is not true too. Resistance to motion of a body, that's friction, I think. Resistance to motion of an object. Okay, that would be inertia, right? So that is not true. All right, so the answer is force per unit area. Even from the formula, we can testify. Now, which statement, number 2, which statement is true about pressure in a liquid? Pressure in a liquid. What are the characteristics of pressure in a liquid? We mentioned that in that video, and we mentioned the fact that number 1 is that it increases with the depth of a liquid. And we also said that pressure at every point of a liquid is the same throughout that point. And we also said that pressure at a point is transferred equally in all directions at that point. Let me really explain what that means. So if I have a fluid inside this container, inside this vessel, for example, now as you go down, you experience higher pressure. So pressure on this point because since pressure is force per unit area, it means that if you are here, you are going to experience a force that is higher than here because the weight of the water, which is still force over area, the weight of the water at this point is heavier than the weight at this point because it's only a little amount of water that is up here that is acting on this area here. Do you understand? So at this point here, you experience higher pressure than you experience at point A here. At point B, you experience higher pressure. At point C, which is way below, you are going to experience higher pressure again than at point A and B. Now, the other principle says that pressure at each point is equal. So that is, at this point here, pressure at this point here is equal to pressure at this point, at this point, at this point, at this point. So it's transferred equally in all directions at that point. And what a convincing factor is an element is also the fact that, remember this formula, H rho G. I'm going to be using formulas also to explain some things so that you know that you can, by understanding the concept of formula, not just cramming it, you can explain some things. So pressure is dependent on height. So as height is increasing, in this case, depth, so as depth is increasing, this is depth 0. So as depth is increasing here, pressure value is also increasing. All right. Then pressure is also dependent on density from what you saw there. Since pressure is H rho G, so rho is density. So as rho, because pressure is directly proportional to rho from what you're seeing here. So as pressure is increasing, rho is increasing, or density is increasing, pressure is also increasing. All right, let's go now. So it says, which one is true about pressure in the fluid? It increases with depth. That's our answer. You don't need to even search further again. It increases with depth. It says it remains constant at all depths. That is wrong. At all depths. If not, H would not be there, or H will be a constant. But H here is directly proportional to the pressure. So, in fact, the height in atmospheric pressure, height is what we use to sometimes determine whether the pressure, the increment in the pressure, the variation in the pressure. Do you understand? Height is what we use to determine. So it decreases with depth. No, it is independent of density. Now that's wrong. Another characteristic of pressure in fluid is that it is dependent on the density of the fluid. You can see it here. So as pressure increases, as density increases here, pressure increases. If you don't understand what I mean by this relationship, I'm going to link a video in the description where I talked about how to understand relationships in physics. All right, relationship in physics equations, physics formulas. Right. Number 3 says, which instrument is used to measure atmospheric pressure? Now, it is not hydrometer because we mentioned in the video of density. I'll try to link that to below. In the video of density, we talked about the fact that hydrometer was used to measure relative density. But the answer is a manometer. Now, pressure in, good. There is atmospheric pressure and there is liquid pressure. So pressure in liquid is measured by a manometer, pressure in liquid. But that of the atmosphere, that is pressure in gas in the atmosphere, that will be barometer. While thermometer, the word thermo means what? Heat. So that will be temperature. So manometer is for what? The fluid. Liquid rather, liquid, not just fluid, because I've told you fluid represents both liquid and gas. So manometer is for liquid. So then, not thermometer, the answer is barometer. Now let's go. And of course, the first barometer was made or built by I think I remember his name as Evangelista. Yes, Evangelista Torricella. So that's why Torricella. That's why the most commonly used barometer is the Torricellian barometer. Torricellian barometer, named after Evangelista Torricella. All right. Now, why do sharp knives cut better than blunt ones? Why do sharp knives cut better than blunt ones? Now, let's remove very stupid answers here. A sharp knife is heavier than a blunt one. Very stupid, because the weight of the knife, of course, sometimes might have effect on what. But you see, a blunt knife can be heavy, and a sharp knife can be light. And both can be heavy, both can be light. So in fact, that doesn't even make sense at all. Do you understand? You see, physics is sometimes you can reason with common sense and understand what if you say a sharp knife cuts heavy, a sharp knife is heavier than a blunt one. Have you ever tried to weigh your knife, or have you ever, the weight can just vary. Do you understand? So weight does not determine its ability to cut. A sharp knife reduces the force applied. Now, how does that do that? A sharp knife reduces the force applied. Maybe that is true, because if I wanted to cut with a very sharp knife, I could just I could just apply a little force and the thing will cut. But is that the reason why it is cutting better than the blunt one? No. It is not cutting better than a blunt one because it reduces the force you apply. You are the one that decides to apply a little force because it is sharp. So you just assume that it will cut better. So that is not a reason. A sharp knife has a smaller surface area, increasing pressure, and that is true. A blunt knife with the tip of the cutting edge, the cutting edge is distorted and it has increased in surface area. Because of that, the increase in surface area, look at it. Let's use the formula. It's very simple. Just follow me. Force over area. That is what? Pressure. Pressure is force over area. It means that if force is increasing, pressure is also what? Increasing. I'm going to link that to the description. Understand how formulas work. If pressure is increasing here, once they are on the same side, as I said in that video, once they are on the same side, up here, pressure is increasing. And if force is increasing, pressure is also what? Increasing. That's why, in fact, here, if force is reducing here, pressure should not increase. Do you understand me? All right. But here, it now says that the surface area is small. So here, if force is increasing, if force is increasing, pressure is also increasing. So it means that area which is not on the same side as pressure, area is on top, area is a denominator, pressure is a numerator, area is below, pressure is above. So if this is the case, the higher the area, the lower the pressure. And the lower the area, the higher the pressure. And I used, now, a typical example is if I could call it a locus classicus. For a lady putting on a stiletto. Is that okay? Now, you will notice or discover that the pressure that this part of our shoe is going to be having on the ground is going to be higher than here. That is why sometimes you will see on the floor, this place will be invaginated, to be entering into the ground as she's moving, especially if it's a sandy ground. Do you understand now? Because the pressure here is higher. And why is it higher? The surface area here is smaller. But here it has a broader surface. So it's not entering into the ground because surface area is larger. Do you understand? So as surface area increases, pressure reduces. All right. So here, a sharp knife has a smaller cutting edge, smaller surface area. So the pressure it will mount will increase. So that is why. And C stands to be the answer. Let's move to the next one. Number 5 says, which of the following explains why a person's feet sinks? Is it covering that? Okay. Why a person's feet sinks deeper into sand when standing than when lying down. Okay, let's think of it. Now, even the concept of stiletto that I talked about the other time, wear the shoe. The stiletto. Now, I'm just trying to draw a stiletto. Now, you will notice that now, which of these surfaces, surface A, surface B, which of them depicts a person standing, and which one depicts a person lying down? So if a person was lying down, this is the way the person will be. The person will be spread abroad on the surface. But a person standing is going to have something like this, right? So pressure is higher when you are what? Standing. It now says, which one explains why a person sinks deeper when standing? So you are going to sink deeper when standing than when lying down, okay? It says because sand exerts more force when standing. That's wrong. That sand does not exert any force. Sand does not exert any force on you. Is that okay? Well, except if you are trying to talk about normal reaction between the surface of your leg and the ground. All right. The force on the sand is reduced when lying down. The force on the sand is reduced when lying down. How do you mean? Your weight is still your weight. So what do you mean when lying down you exert less force? That doesn't make sense still, but it may be convincing, but it doesn't make sense. The next one, the weight is distributed over a larger area when lying down, yes. So when you are lying down, for example, so see a person lying down and see a person standing. I'm using stick images. The weight of this head will be felt, so they are both on the ground. The weight of this head will be felt by here, the weight of this chest here, the weight of this butt part here, the weight of this leg here. So you see that the weight or the force of that guy is spread abroad here. Unlike here, the entire weight is acting on these two places. So because the surface area here is smaller and surface area here is larger, here force is lower because there's more surface area. Consider the formula again. Pressure equal to force over area. Surface area is plenty, so pressure will be lower. Do you understand? That's why you will not sink if you are lying down, but you will sink if you are standing because your weight is distributed over a large surface area when you are lying down. Does that make sense? Yes, ma'am. Does that make sense? Because here it said pressure depends only on depth. No. We also said that pressure depends on density. Pressure depends on your weight, so pressure does not. So he says the weight is distributed over a larger surface area when you lie down. So because your weight is distributed over a larger surface area, you can't sink because it is not one part that is feeling your entire weight. But here, when you are standing, it is one part that is feeling your entire weight. All right. Let's go to the next one. Why do deep sea divers wear specially designed suits? A, to protect against cold temperatures. Well, that might make sense, but it doesn't have anything to do with pressure because, yes, the deeper you go, the cooler it becomes. Of course, until you now get to the base of the sea, of the ocean, where we have hydrothermal vents, that is even hot. Okay, but the deeper you go, really, the cooler it becomes. But no, but that is not the case here. The next one is to help them breathe underwater. Now, we talk about suits, not exactly the breathing device. Sometimes in their suit they have breathing device attached, or some of them carry oxygen tank. So that is not the. Yes, mommy. Okay, so we said that it is to help them breathe underwater. We said no, it wasn't to help them breathe underwater. Then to withstand high pressure at greater depth. Yes, that is why their suits are built, because we said pressure increases with the depth of the fluid. So as the depth increases, the pressure becomes way higher to the point where they cannot even their hearts might not be able to pump again. Do you understand? So it could crush even the body. Do you understand? So that's why they are built those specially designed. Those suits are specially designed for divers. So the answer is to help them withstand high pressure at greater depth. The next one says, what happens to atmospheric pressure as altitude increases? What happens to atmospheric pressure as you increase in altitude? So since pressure increases with depth, it means as you go up, what will happen to pressure? It will reduce. So the answer is it decreases. The next one, which principle explains why a hydraulic press amplifies force? So that would be Pascal's principle, because Pascal's principle says that when pressure transferred, it says that pressure transferred within a confined fluid is transferred equally in all directions. Do you understand? So that's Pascal's principle. And in fact, Archimedes' principle is about density. So that is not. And Bohr's law, is about pressure and volume. So not that. And D does not even correlate to Newton's first law. All right, the next one. Why do drinking straws work? The answer is, do you know when you draw something with a straw, what happens is that you suck up the air. So as there is no air available inside, atmospheric pressure pushes down on the fluid, and because atmospheric pressure is constantly pushing down the fluid, it's going to enter into the straw with because the space that was occupied by air in the straw has been removed. That is, the air has been removed from the straw, so it pushes up the fluid into your mouth. So it says the liquid is sucked by the straw and sucked into the straw by the mouth. That's rubbish. Atmospheric pressure pushes the liquid up when air is removed from the straw. Gravity pulls the liquid into the straw. Okay, no, gravity acts downwards, so it doesn't pull the liquid into the straw. Is that okay? The liquid moves due to capillary action. Of course, but this one is suction. So capillary action doesn't even need suction to work. Is that okay? All right. So that will be it for this video. Now, this is number 9. The number 10 question will be posted as the first comment. So make sure to check that first comment and give your own answer. Is that okay? That will be the number 10th question. Do also subscribe to the channel as I post content that are very helpful for your passing of the JAMB. God bless you, and as you ace your exams in Jesus' name. Amen.